Bismillah ar-Rahman ar-Rahim. Let's look at this problem. This is from an old exam problem. We need to determine the reaction at the supports. So we have a reaction here. This is the pin. This pin has a reaction on the x-axis. I call it AX. And there's a reaction at the at the y. I call it AY. And this is the pin, and this is a ruler. The ruler has only one reaction perpendicular to that reaction. I'll call it PY. There's also a distributed load, but this is a triangle distributed load. And also we have a moment at point C. Now, our first mission is to change this loading into a point load. So I'm going to make it colored. So this is equivalent to one force here, and that is equal to 1/2 times 9 times 30. Let me do the calculation here. Of course, 1/2 times 30 is 15. 15 times 9, and that is 135. And you can see it's kilonewton per meter, but since it's multiplied by 9 meters, it will be in kilonewton. So this is 135 kilonewton. Okay, the distance. It should be 1/3 from the base here. 1/3 of a 9 is 3 meters. And the rest is 6 meters. Okay, so let's do a free body diagram. This is A, we have AY, we have AX, and we have the point load or the equivalent force, 135. And also we have PY, which is unknown also. And we have point C, there's a moment at point C, 180 kilonewton meter, and the distance is 4.5 meters, and from here to here is 9 meters. Okay, as we mentioned in class, the first thing to do, what he wants right now, he wants AX, AY, and he wants BY. The first things that he should do is to do moment at too many unknowns. So the point where there is too many unknowns is this point. So we should do summation of moment at A. So summation of moment at A equal to 0. And I'm going to assume this direction is negative. This will make this force create a negative moment. You can see that this will rotate clockwise around point A. So negative 135 times the distance perpendicular from that force to point A, 6 meters. Okay, what else? We have this force, By, but you could notice that this By will create a moment counterclockwise. So it's a positive plus By times 9. Okay, and also there is no more forces, but there is a moment here at point C. And you could notice that this moment is clockwise. Okay, this moment is clockwise, so it is negative, minus 180. A lot of students multiply this moment with the distance from here to here, 4.5 plus 9, 30, and that is wrong. This moment is a moment. You just added to the summation moment without multiplying it with any distance at all. This is equal to 0. So this is 135. So you do the calculation here. By, it will be plus. So by, it will be 110. And of course, kilonewton. And since it's a plus, that's it. Our assumption is correct. It's up. As you can see it here. It's up. I assumed it already up. After that, we found the rest of the equation. Summation of forces at x equal to 0. Now, you can notice here there is no other force but AX. There is no other forces in the x-axis. So x is equal to 0. We'll do the last equation, summation of forces at y equal to 0. And of course, we're going to assume up is positive. And this will have a y minus 135 plus by. By is 110. And there is no need to add the 180. Okay? So ay minus 135 plus by equal to 0. And then you could find ay equal 25. And it is plus. It is plus 25 kilonewton. And where is the ay? Ay is up. So it is, our assumption is correct. This type of problems, and to find the reaction, especially if you have like a hinge or if you have the ruler, is very easy. Whether the distributed load is triangle, whether it is rectangular, no one should make any mistake in this type of problems. But also we should notice if you have a fixed support. We did this in class. And of course, let's say if you have a distributed load here. Let's say we have the same distributed load, 30. And you have same distance, let's say 9 meters. And you need to find this support reaction. We do the same thing. Let's say this is A. So we have AY, AX, and moment at A. Eventually, you should start by finding the equivalent load. 30 times 9. Let me just do that with the calculator. 30 times 9, and that is 270 kilonewton, and the distance from here is 4.5 meters, and the distance from here is 4.5 meters. The first things we do is to find moment at the location where there is a lot of unknowns. So summation of moment at A equal to 0. This is the assumption. So this will give you this moment that you have to include. Moment A, and that is negative moment A because you can see it's clockwise. And this force will also produce a moment also clockwise, minus 270 times 4.5 equal to 0. So 270 times 4.5, this would give you moment A negative 1215, and you can see that it is kilonewton meter. And since it's negative, which means that our assumption is wrong. So MA is 1215 kilonewton meter. We assumed it clockwise, so it is counterclockwise. Okay, you should do it either this way or counterclockwise like this. You should have magnitude, you should have unit, and you should have direction. Whether you put it like drawing an arrow counterclockwise, or you just make it CCW. That is the first one. Next, you should do summation of forces at x equal to 0. This is the assumption is positive. And you can notice in this beam that there is nothing but ax equal to 0. Summation of forces at y equal to 0. Assuming this is positive, and this will have a y up, let's see, minus 270 equal to 0, which means that ay is 270 kilonewton, and ay is positive, so it is correct. Now, whether it comes as a hinge, there's two reactions. Whether it comes as a ruler, it's one reaction. If it's come as a fixed support, we know ax, ay, and there's a moment. It is best to find summation of moment at A or at that location in order to cancel ax and ay and to include the moment for that fixed support and find it. We will see you in the next question. Thank you.